and taken account of when you're getting to know and have an awareness of issues related to quantitative research. Now, the next slides really talk about quantitative research and the different types of quantitative research out there. So the first bit, and when we talk about quantitative research, remember, it is really to do with cause and effect relationships. That's pretty much what quantitative research's interest is about. Of course, there are variants in this journey for understanding of cause and effect, and those variants are what we will look at. So, before we go into quantitative research itself, we just need to know what the purpose of a research design is in principle. When we talk about a quantitative research design, what purpose does it serve? Because once we understand that purpose, then we know that when we choose a particular design, it's going to be able to achieve certain things for us. So the first thing is that the research design provides a plan or blueprint for you to test any of the research questions that you're interested in. It also allows you to test hypotheses. A hypothesis is basically a statement of what you expect to see when you study something in terms of the relationship that you're looking at. So a research design allows us to test out these research questions, and it also allows us to check if the hypotheses that we have are indeed accurate. It also gives us a structure and a strategy so that we can maintain some type of control and over how we go through different steps of the research process. And it also allows us, it ensures that the things that we do subscribe to a particular way of thinking. So this whole intervention fidelity relates to that. Now, of course, when you talk about quantitative research, there are specific things that are key and important aspects that should always be taken account of. Remember that in quantitative research, one of the primary characteristics that separate it out from any other design is that it boasts about its objectivity. That ability to represent things as unaffected facts that are not subjected to value judgments or anything of that nature. So that objectivity. So in quantitative research, you prioritize this quest for objectivity in the way that you develop the research question. So someone would say, look, you have to use objective concepts in your research question so that you can measure things and you can articulate your phenomena of interest in an objective way. That's the first bit. Then, of course, the other thing is that in quantitative research, there are different options within quantitative research, and each of them, once you choose that option, it commits you to certain things. And each of those options are associated with varying levels of accuracy. They are also associated with different levels of feasibility, the fact that are they possible or not. So if you choose a true experiment, for example, then of course you now need to create experimental conditions, laboratory type conditions. And you may discover that the thing you're looking at does not allow you to do that because it just is not feasible. Then there's an expectation that when you do quantitative research, you need to have a control. And in essence, a control is a sample that has the same characteristics as the one that you call your study sample. But that sample in a control is a sample that does not get subjected to whatever the intervention that you're doing is. So we call that a control. The sample that doesn't get the intervention that you're interested in, or the intervention, the sample that is not exposed to the independent variables that relate to your study. So that's called a control. Then, of course, remember, we're interested generally in quantitative research, we're interested in the issue of whether a particular action will result in a particular reaction. So that action that we speak of, we need to be clear that when we say someone has been exposed to action A, we really mean that they've been accurately exposed to action A. It should not be that we say, oh, they were exposed to this, but only to later discover that they were not exposed to it properly and so forth. So quantitative research expects and assumes that the intervention whose effect we're measuring is applied the same to different subjects. So we know that we are really measuring the effect of the same thing. Then, of course, we talk about issues to do with validity, internal and external, and that we will reflect on when we later on in this presentation. So now there are essentially in research, quantitative research, there are three types of designs that exist. And here I describe two of them, and I will orientate you to the third design. But essentially, when we talk about quantitative research, we have experimental quantitative research. And basically, as it says, that's research where people actually do an experiment. They manipulate something, they introduce an intervention, and they watch its impact on whatever it is they're interested in. They carry out an experiment. Then we have what they call quasi-experimental designs. And quasi-experimental designs differ in that they are sort of, or this prefix quasi means almost. If you go and you check up what the word quasi means, that prefix, it usually means almost, or it means similar to, or it means something that emulates. So when you say it's a quasi-experiment, you're saying it's similar to an experiment or it emulates an experiment. And so when we talk about quasi-experimental designs, they're experiments that haven't met all the golden conditions of an experiment. So they are almost an experiment. And I will show you what differentiates a true experiment and a quasi-experiment. Those are the two different types of quantitative designs. Then, of course, the final design, which is also segregated into other smaller bits, is the non-experimental design. And with non-experimental design, we're basically saying that no intervention has been inserted by the researcher, and the researcher is just observing the action that particular interventions have on things. And that observation is a non-experimental observation. So instead of you being the one who injects the cause and you watch the effect, in a non-experimental design, you would know that there's a particular action that's going on and you just observe. As a researcher, you observe what effect that action has. So you don't engage yourself in actually putting in the experimental work, the experimental intervention. All you do is you assess it as with an observer status. So these are the three types of designs. Broadly speaking, there's the experimental design, quasi-experimental design, and then there's a non-experimental design. And each of these have categories underneath them. So you will be exposed to those, but in general, that's what the different design spaces in quantitative research look like. So now from that, we talk about a true experimental design. The first one, and I need to explain to you, the experimental design. It generally has three properties. And these three properties are what make it an experiment. So for something to be an experiment in the true scientific research way, it must possess three characteristics. And these are three characteristics that make something a true experiment, or make something fall under the true experimental design category. Firstly, the first property is that it must have evidence of randomization. And that evidence of randomization relates to the fact that in your selection of a sample, or in your selection of the subjects for your study, you must show that you selected them through a randomized process, a process where you chose them through statistical and mathematical probability. So that's the first characteristic. If something has that, or for it to be a true experiment, it must at least have randomization. It must also have control. That control is the existence of an equal sample or subject group that does not receive the intervention that you're interested in. So a control, if say I wanted to know whether watching television causes people to have epileptic fit, I would then say, look, the control is that I must have people who do not watch television. So I can say how those who watched television can be compared to the ones who did not watch television. Then so that's the existence of a control. So anything that's an experimental design will have randomization, and it will have a control. And also the last thing that it must have is it must have manipulation. i.e., and what I mean by manipulation is that it must have a distinct intervention that occurs. So for something to be an experiment, there's got to be some intervention that you have injected into the process. And so a true experiment has randomization, control, and manipulation. And a typical example, or the way that we refer to true experiments normally, is we call them randomized clinical trials. That's a typical example of one. But now, the next slides basically speak you through, define some things that I've already spoken about. This slide tells you what randomization is. And I'll leave it there for half a second so you can read this, but I have already explained to you what randomization is. The next slide refers to this concept of control. So remember, control is if I'm interested in a particular intervention and its effects, then control means assessing a group that have not received that particular thing that I am interested in. So that represents, they then get called the control group. And then finally, the last characteristic is manipulation. That relates to the ability, basically manipulation relates to the researcher's control and interest in being able to inject a particular intervention so they can assess its outcomes. So if you were interested in the effect of television on particular behaviors, then manipulation is actually you exposing people to television. If that exposure to television was not controlled by you and was controlled externally by individuals without your control and you are just observing it as a researcher, then you would not be manipulating it. So it then means that what you're doing is not a typical true experiment. So, but now I've said to you that a true experiment has each of these three things present: control, manipulation, and randomization. Now, a quasi-experiment, which I remember quasi says almost. So it's an experiment, but it's missing some characteristics. And basically, with quasi-experiment, it must always, by virtue of it being called experiment, it involves a manipulation, but it may not have the other two things. It may not have control, it may not have randomization. But not so if an experiment has got two of the three characteristics of a true experiment, then we call it a quasi-experiment. Now, what I have got here is I've included some examples of types of quasi-experimental designs, and the one in particular that should be noted is this non-equivalent control group design. So basically, when you say non-equivalent control group design, what you are saying is that, remember we've said that anything that we call an experimental design, whether it's quasi or not, must definitely have manipulation. That is an intervention that is occurring. But it does not necessarily need to have control or randomization. So a non-equivalent control group design means that it's a quasi-experiment that has got some control. It's got a group that's receiving and a group that's not, but it does not have randomization. And the reason you know that it only has control but no randomization is because if it's a quasi-experiment, it means it can only have one of those two. So if it has control, then it definitely does not have randomization. These subtypes of quasi-experimental designs are at this stage probably a little too advanced for you to concern yourself with. But at this point, what you really need to know is that in quantitative research, there are three design groups that exist. There's the experimental design, the quasi-experimental, then the non-experimental. And each of them have got subgroups underneath them. Now, what also happens is that in quantitative research, of course, we spoke about those three designs, but there's the non-experimental design is the one that is most fascinating and offers much more leeway for people normally at the level of study that you're at to engage with. So it will be a type of research where you are, rather than injecting things or introducing manipulation, your interest is to understand relationships of naturally occurring cause and effect relationships. So really, in many ways, we want to just call it observational research. That you'd be interested in how A affects B, but you don't go and buy A and introduce A. All you do is you look for situations where that variable that you're interested in is occurring, and you use those situations to understand what the relationship between the observed intervention and the outcome that you are interested in. That's basically what you are doing when you are you do correlational research of any type, where you basically are looking at pre-existing actions that are going on, activities, processes, phenomena, and you start to assess the type of relationships that exist between things, independent variables, and a dependent variable that you're interested in. Very rarely will you yourself actually be the person introducing the manipulation that we're interested in. So in many respects, it's the correlational research and the causal dash comparative research that becomes the biggest umbrella under which many of the studies that you have will fall. So I've once again spoken about the issue of non-experimental designs. So those designs that I've mentioned, the correlational ones, the causal, so comparative designs, are all examples of non-experimental designs. And the one thing that makes something non-experimental is that it does not possess manipulation. And remember, people can do non-experimental design when they want to create a picture of the phenomena that they're looking at. They want to explore that phenomena without necessarily themselves inputting any particular intervention to change it. They are literally just going to understand and assess the phenomena that they're interested in. And of course, it allows you to test relationships and any differences that may exist between variables of interest. Once again, as I've said already, in non-experimental designs, the independent variable, the things that you need to be manipulated, you do not manipulate them, you just observe them. And of course, the way that you've selected things does not necessarily meet the randomization expectations. And of course, because you have not manipulated anything, you have not carried out an experiment, there is no control group to be had. So non-experimental designs have none of the three conditions of experimental designs. They do not have the randomization, they do not have a manipulation, they certainly do not have a control group. This, what you have in front of you, is just a quick slide that helps you to compare experimental to non-experimental designs. And of course, everything that it speaks to around manipulation, randomization, and a control group are all things that have been discussed and described up to this point. And as I've said, the examples of non-experimental research is research that's interested in correlations or relationships between things. And then, of course, research that looks at comparing the causes of one thing to the causes of another. So this causal stroke comparative research, both these types are non-experimental examples of research. So correlational research it's research that's interested in understanding the interrelationship or association between two variables. So if you are interested in two variables, then that is a correlation. And remember, talks about the two-ness, the couple, and the coupling. So correlation research is about the interrelationship or association between two variables. And the slide that I have gives a couple of examples of the types of correlations that we regularly meet and may be quite familiar with. I will not go into detail on them. I'm assuming that you will have had an opportunity to read them. And we've spoken about correlation. Then there's what they just call, in a much more generic way, relational research. It's really about research that examines relationships. And then the research questions usually in relational research reflects, is interested more beyond just describing the single characteristics of variables of interest, but it goes on to understand whether a relationship between variables or subjects exists. And in relational research, there is no requirement under the umbrella of relational research for it to only involve two variables. So relational research can be about relationship between two variables, three variables, four variables. It is more to do with it being research that's interested in relationships. And in that, of course, correlation research is a part of relational research, but we know correlation research to be about two variables being related to each other. Then there's also predictive research, which literally is relational research, but with the primary purpose of being able to offer adequate understanding of the causal relationship between things so that you can predict how the existence of one factor or variable is likely to result in a particular outcome. Now, I've explained already what correlation research is, but I will leave the slide up for 30 seconds or so you can just quickly catch a quick glimpse and understanding of how others have captured this definition of correlation research. Remember, we speak about research being logical. So every time I may introduce you to a broad option, then in it there are sub options, and those sub options have sub options. So we spoke about experimental, quasi-experimental, non-experimental. And when we get into non-experimental, we then have correlational research, causal, comparative research, and so forth. And under correlational research, we'll find that there are also other things that exist below it. And this is the part that this is the part at which the whole decision-making tree makes it much more difficult for one to be absolutely certain that the findings of or the way that they approach their study is the same as the next person who did the same study, because there's so many options that you have to go through. Okay, so remember, correlational research itself is, in broad terms, is research that's looking at the relationship between two variables generally. There are other forms of correlational research that may involve more than two variables, but the issue is just to do with the relationship between two variables in and that understanding of the relationship has no manipulation in it, no controls are put in, and no randomization is expected. So in correlation research, when you're looking at the relationship between two variables, there is a type of sub-design called a retrospective design. So it is, you're interested in the relationship between two variables, but you are interested now in how a phenomena that exists today may be linked to something that happened before you even looked at this thing that you're interested in. So if, say, now you are interested in people's performance at university or wherever they are studying, but you are interested in whether their parental relationships have any impact on their performance now. So you are interested in their performance that is occurring now, but you want to see its link to a phenomena that occurred before you started your study. So that is a retrospective design. And of course, remember, if you are interested in something that happened a long time ago, you can only have what we call a cross-sectional understanding of that something. If you're interested in how someone's upbringing contributes to their performance in exams, you are able to assess their upbringing in a cross-sectional way by saying, look, you want a summative overview of the contribution of X. You can't ask them to look at the contribution of X on Monday, Tuesday, Wednesday, 10 weeks ago. So you will notice that retrospective designs are often cross-sectional in nature rather than longitudinal. And both the data that we are interested in as the outcome data and the data of this phenomena that occurred before initiation of the study, both those data sources will be cross-sectional data sources. You may want to pause and really give thought to what I've just said. Now, the opposite of prospective or retrospective designs is this what we call prospective designs in correlational research. Now, an example of a prospective design is a cohort study. So basically what you're doing is once again, it's a correlation study. So you're interested in the relationship between two variables, but it's a forward-looking study. So you've identified what the independent variable of interest is, and what you're going to do is to watch it over time. So in a prospective design, you would be saying, look, I'm interested to know whether exposure to violent TV has any impact on people's tendency to be violent. So what you do then in a prospective design is you go and you watch those people who are being exposed to violent TV, and you watch them over some years or some time as a cohort. And on the basis of that watching, you then look at how the outcome of interest, their tendency to be violent, for example, appears to have been impacted on by their exposure to violent TV. So rather than looking at their previous exposure, you are looking at the future exposure that they have. And of course, different scenarios will require different things. So you'll find that many people who are doing qualification-related research, such as yourself, will go for retrospective designs where you look for pre-existing data so you understand the relationship between two things by observing something that has already occurred or trying to get records on something that has already occurred. The idea of doing a cohort study is a little bit more feasibly difficult for course-related research, because sometimes people say, hey, you have to watch somebody for 5 years to figure out what's going on. So in a study where you're hoping to finish your PhD within 5 years, you could not really spend 5 years understanding the outcomes of a particular cohort by just watching them for 5 years. So this prospective design in correlational research is good to know about, but you may discover that it has some practical challenges as far as doing qualification research related research. But nonetheless, the differentiator that you should be aware of is that there's in correlational research, there's prospective design, and then there are those designs that are called retrospective. And one relates to you and exploring the independent variable that has already occurred, and the other is to actually track the independent variable going forward for a period of time. So remember, in correlational studies, there is another type. As I've said, that in correlational studies or correlational research, there's a wide range of hybrids that exist or typologies. One of them is this descriptive correlational research, which really whose purpose is just to observe and describe the natural occurrence of something that is of interest, and then to use what you see as a starting point for generating hypothesis. And then once you have that hypothesis, you use that hypothesis then to give you a sense of what you want to be interested in, so you can describe the relationships that you think are occurring, rather than to really have a numeric way of saying this A causes B. So descriptive correlational studies tend to describe the phenomena more as a narrative rather than actually try to numerically or mathematically infer that A causes B and the power of causation is such and such. So yeah. Of course, all these correlation examples that I've given you, they have strengths and limitations. And this slide highlights some of those. Of course, in the world of quantitative research, where the true experiment is the golden standard, anything that does not have the ability to manipulate the independent variables to see what manipulation does is therefore considered to be weaker. So by definition, correlational research will be seen as weaker than experimental research because it's harder to establish the causal relationships when you don't have a perfect experimental space to test whether when you inject A, does B happen. Correlational studies don't have that true experimental environment to test the causal relationship, so it's weaker in that sense. Of course, a lot of the times you're watching things that have occurred and you have to make interpretations of what is happening. So if your skill of interpretation is weak, then you subject that process of research to more faulty interpretations being possible. Then, of course, there's what we call confounders or confounding variables. These are variables that may affect the outcomes and are already pre-existing. So if, say, for example, I wanted to know in correlational research, I want to know if people who traditionally watched TV 20 years ago became violent or not. The role of their own character, the role of the upbringing that they're coming from, the role of other social influencing factors is much difficult and more complex to identify and quantify in correlational research. So the complexity of confounders is much more difficult to quantify. Whereas the strengths are that, it's a very good way of offering an alternative way of understanding cause and effect when you don't have access to experimentation. You don't have the ability to actually manipulate things, but you can observe them. And then, of course, by virtue of it being quantitative, you can collate large amounts of data about large sizes of groups in a relatively inexpensive way. And then, of course, there's argument that correlational research, by virtue of not imposing a true experimental space for the researcher, it allows for greater chance of realistic ways of seeing things, and therefore it is much more useful in practical problem solving. Now, we've spoken about correlational research. Its sister or similar non-experimental option is this causal comparative research. And this is very similar to correlational research, but just one or two standout differences that are captured in the slides that proceed from this one. Okay, so the aim of causal comparative research is to determine the cause of existing differences between groups. So whereas correlational research involves collecting data on two or more variables that relate to one group, so you in correlational research you have one group, then you look at two or more factors and you study the relationships between them in relation to that one group. Causal comparative research, by contrast, may involve the same two different variables, but it involves the collection of data on two or more groups, for two or more groups. So you may see two or more groups that are different. In one particular way, in which case we might say two or more groups that differ on their teaching style, for example. And then you attempt to understand the reason for these differences. So basically, if something is correlational research, is interested in one group, two or more variables related to one group. But when it comes to causal comparative research, you have one variable that you're interested in, but you're looking at that variable across two groups. So I hope correlational research is about one group, your interest in one group, and then your causal comparative research is about your interest between two or more groups, but how they are affected by one variable. So correlational is more than one variable on one group. Causal comparative is more than one group in respect to one variable. You may want to slow that down or take the slide and slow it down a little bit, because those are the distinct differences. But they are essentially similar activities that occur. But in correlational research, the activity is related to one group, and in causal comparative research, the interest is related to two or more groups. Now, causal comparative research, of course, is non-experimental, and by that virtue, it differs from experimental research in quite obvious and expected ways. One, there is no manipulation of the independent variable. So in causal comparative research, by virtue of it being non-experimental, you do not manipulate the variable. In causal comparative research, the thing that you would have manipulated has already occurred. So yours is to observe it. But your interest, once again, is to observe it, that one particular variable, and observe its impact on more than one group. So that's literally what the difference is. What I have done with this is just to assist you, is that you will notice that causal comparative designs and experimental designs are all part of this whole quantitative world, where the intention is to determine the cause and effect relationship that exists between a particular independent variable and different outcomes in different groups. But ultimately, we are of, they all achieve the same thing. The only difference is one, is that in true experimental research, the owner of the research has the ability to actually manipulate. The owner of the research has the ability to actually manipulate the variable. But in causal comparative designs, the variable has already occurred. So they don't manipulate it. All they do is understand its impact on two or more groups. And of course, in this world, you can have a single factor, causal comparative design, two-factor, multi-factor. And basically what that means is single factor causal comparative design means that you have one factor that you're interested in, and you are looking at its impact on two or more groups. But if you have two factors, you might have two related factors, and you want to know how those two related factors affect two or more groups. And then multi-factor, you have multiple factors that you're interested in, and you're interested to see how they affect these two or more groups. I have offered more similarities between these, and I have just captured them here as slides of note for you, but we will not discuss them because really you only ever really get into this when you are in the depths of doing causal comparative research. If you're someone who just needs to know, the one thing you just need to extract from this is that causal comparative designs are about, it's a form of correlation. It's a form of a correlation, but this correlation is particularly notable by the fact that you are interested in the differences that result in two or more different groups, and those differences arise from one factor. Of course, when you do observational research, as causal comparative designs are, the fact that you yourself are not the person who introduced or manipulated the intervention means that your claim to the fact that A causes B is that much weaker, because you're not the one who injected A into this relationship that you are trying to assess. Whereas in an experiment, you're the one who would have actually taken the independent variable and introduced it. So you can be much more clearer about the fact that the triggering of the response came from your own activity. Now, what I've done, and this is for those of you who proceed on to do much more substantive work around causal comparative research, is my next few slides, I think it's the next 5 or 6 slides, which you will have access to when you get the full remit of work. They just go through examples of causal comparative research and how you can identify something as being causal comparative research and so forth. So the final bit, now I will jump those slides. There's 3 or 4 of them. When you receive the actual hard copy version of this, you'll be able to see those slides. But what I will do is just get to the last slide that relates to causal comparative research and the value that it brings to the whole world of research. So you will notice that causal research or comparative research, causal comparative research is particularly helpful in that it will give you an initial sense of the things and the relationships that are worthy of further exploration. So you will observe something without actually experimenting, and only when causal comparative research outcomes tell you, then you are able to say, look, I now want to subject this to a true experiment. So they save you from carrying out unnecessary experimentation on issues and factors that have been shown to have no relationship to each other. And of course, you and I are aware that there are many things that cannot be done through experimental design. You can't say you want to know what the impact of a teacher who ignores their students is on their progress, because then you would have to expose students to being ignored, which we know is not good and so forth. So for many reasons, causal comparative research offers options where experimental research would not have done. It is, of course, less expensive and time consuming because there's no requirement for you to inject an intervention. And for many of you at the level that you are at now, if you're not going to do a quote unquote true experiment, it is very likely that you are going to be looking at causal comparative research or correlation research of some sort, but all of which will be non-experimental. Now, the next thing, and this I will run through very, very quickly, is that in quantitative research, one of the primarily used approaches to quantitative research, and this is the tool that people will use to do correlational research. It is the tool that people will use to do causal comparative research, is this use of the survey. And I've included it here because it's an explicit data collection approach, one that many, many people struggle with and have lots and lots of questions about. And nonetheless, it's used. So what I thought was important was to really get to the bottom of it. And remember, survey research involves the use of self-completed questionnaires and so forth and so forth. So when you do quantitative research, for many of you in the human and social sciences particularly, this is the primary data collection option that you will be utilizing and referring to. So I know I have depicted and explained what survey research is, but I want to do that so that you can see what it is that makes something a survey. And if that is not in existence, then whatever it is that you're talking about is not a survey. So when you obtain information from a sample by self-report, i.e. when the sample themselves report to you what it is that what their responses are, and if the reporting and the collection and that is a survey. So when someone collects the information and gives it to you themselves, rather than you hearing it from them, then recording it and so forth. Now, when they record it and it's given to you by self-report, that is a survey. There are different forms of surveys, and I will explain them to you very quickly. Surveys may be descriptive, exploratory, or comparative surveys. So basically, you can use surveys where you ask people to answer by describing things. You can use a survey to explore people's views about phenomena of interest. And then, of course, you can have a survey when you use it to do comparisons that people have between certain views and feelings about certain things. So it is one of the tools that's regularly used in comparative, causal comparative, or correlation research. Of course, a survey may be cross-sectional, that is carried out at a particular point in time, or longitudinal, where someone is asked to complete surveys over a length of time. Then, of course, they allow you to collect detailed descriptions of existing variables. So with surveys, generally the survey creator will say, these are the 40 things that matter to me, and I will ask you about those. So, but if it's possible that the phenomena being studied has 45 things, the 5 things that are not asked about by the researcher will then, of course, obviously also be omitted by the respondent, because the surveys generally have pre-described and articulated variables, and the respondents answer those. So, of course, with surveys, they are very flexible. They can be used on small samples, middle samples, large, broad, narrow type samples. And when we say broad samples, we mean a sample with people who are not homogeneous, people from different backgrounds. You can have a survey with that focuses on 20 different groups, or you can have a survey with one group. So they can be broad or narrow. And of course, a correctly written up survey cannot be used to extract information that could determine causation. So the minute you are using a survey and you want to determine whether A causes B, then you know that the confidence level of that work will be so low that it is unlikely to really be able to determine causation. But what they can do is they can give you a sense of whether there's an apparent relationship between variables by asking people whether they think A led them to do this. But you cannot say the perception of a relationship is not the same as confirmation of causation. And I think that is clear. So remember, I explained to you that with surveys, they can be exploratory, descriptive, or comparative. And you may, when you describe your own survey choice, indicate whether you are doing a survey to explore things, a survey to describe things, or a survey to compare things. And that is predominantly there. So, of course, with surveys, depending on the nature of how they are constructed and so forth, the things that you collect range from anything that can be classified as opinions, or sometimes to attitudes that people have, or sometimes facts. And when it comes to facts in a survey, you would have phrased the survey items in such a way that people give you factual responses in terms of how they perceive, see, or have experienced things. So fact variables are things that are factually determined. For example, in a survey, you can ask people to indicate their gender, their income level, their political and religious affiliation, their age, and so forth and so forth. And of course, when you get that information with factual survey information, you're able to develop particular interventions or describe a group, really. I mean, they allow you to describe what it is you see. Now, everybody has always assumed that surveys must mean that people complete a paper. And what I want to share, and especially in the context of the COVID-related restrictions that we have, surveys can exist as different subtypes. The first subtype is this issue of what we typically know to be surveys, self-administered questionnaire. So remember, a survey is anything that relates to self-reporting. So when someone reports on themselves, whether they do it via a questionnaire, whether they do it via an interview, whether they do it through telephone, or whether they are assisted by an automated computer questioning contraption, whether they do it, they report through working with a panel of experts or not, all those are surveys. And what I have done here is just included some of the subtypes of surveys. And I think there are a few slides that help to explain these subtypes. But as they stand, really, they are self-explanatory. I think the big thing that you should know is just the idea that you can do surveys that don't involve the traditional self-administered questionnaires. And especially now with options of electronic possibilities and so forth, you can do computer assisted surveys and so forth. And these are all written about, they exist and they are there. Now, I've put some information here. There's some further reading that you can access in terms of this. I've also provided additional reading on issues to do with the hierarchy of evidence and so forth. And you'll remember when we spoke about much earlier on, I identified a hierarchy of evidence which was presented in a pyramid, and I said it was developed by a person called David Sackett, and that is the last reference that you have there. And folks, so up to this point, if you watched the first short presentation that I did, I was introducing some basic quantitative research principles that I expected you to have. Then the next section looks at differentiating between experimental, quasi-experimental, and non-experimental designs. And then I took one of the modes of data collection used within quantitative research, and I've shared that with you, and that is the survey and its different permutations. And then what is outstanding, and this is what will be done with our next session, is to introduce you to this whole thing of developing or choosing the population that you will study. And this relates to the sampling plan, issues to do with population and data collection and analysis, and all the perspectives around quantitative sample strategies. And this will be what the second session will be about. Please feel free to retain any questions that you have from the first section, so that when we have our next live presentation, you are in a position to ask those. Thank you. Thank you very much. I hope that you found this useful. And remember, everything that you're shown here is just an introductory perspective, so you are able to then pursue things much more assertively. And we will share this presentation. There are a number of slides that I didn't show you, but are available for those who look at the hard copy version of this. Thank you.